So in this module, we shall cover the process of deploying the DApps we built on the Ethereum blockchain. First, to deploy, we compile the smart contracts. The first step in deploying the DApp is to compile the smart contracts that power its core functionality. Then we deploy it to Ethereum. Once the contracts are compiled, they can be deployed to the Ethereum blockchain, making them accessible to users. This involves sending the contract code to the network and setting up the appropriate configuration. Then we shall host the frontend. To provide an interface for users to interact with the DApp, the frontend must be hosted and made available online. We shall set up the environment. First, we install Truffle. As we know, Truffle is a popular development framework for Ethereum that simplifies the process of building and deploying smart contracts. Then we install Ganesha. Ganesha is a personal Ethereum blockchain that you can use to run tests, execute commands, and inspect state while ensuring the behavior of your application. Install it globally to have a local development environment for your DApp. Then we shall set up the project. We should now create a new Truffle project and start building the DApp. This will provide the necessary file structure, configuration, and tools to develop and deploy the smart contract. To prepare to deploy the DApp to the Ethereum network, we first need to configure the deployment settings in the truffle config.js file. This file allows you to specify the networks you want to target, the settings for each network, and the Solidity compiler version to use. In the example provided, this configuration sets up two network environments, development for local testing and Ropsten for deploying to the Ropsten test network. For the Ropsten network, it specifies the provider to use, which is Infura in this case, and the network ID, gas settings, and other important parameters to ensure successful deployment. To deploy the local network, first we start Ganesha. So we launched the Ganesha blockchain simulator to create a local Ethereum development environment. We then migrate contracts. We use the truffle migrate command to deploy the compiled smart contracts to the local Ganesha network. Then we verify the deployment. We check the Ganesha dashboard to confirm that our contracts have been successfully deployed and are accessible. By using Ganesha, a personal Ethereum blockchain, developers can quickly and easily test the smart contracts in a controlled environment before moving to public test or main networks. To verify deployment, we first check Etherscan. This verifies the deployed contract on the Ethereum Block Explorer. We then enter the contract address. We copy the contract address and paste it into the Etherscan search. Then we shall review the contract details. We inspect the contract's code, transaction history, and other metadata. After deploying the DApps, it's important to verify the deployment on Etherscan. Etherscan is a popular block explorer that allows you to search for and inspect deployed contracts on the Ethereum blockchain. Now we shall host the front end. So we first prepare a React-based front end for deployment. We create a production-ready build using the npm run build command. This command optimizes our application for performance and generates static files that can be served by a web server. We then minimize the bundle size. The production build process ensures your application's JavaScript, CSS, and other assets are minified and optimized, reducing the overall bundle size. This helps improve the loading speed and performance of our decentralized application. We then serve the static files. With the production ready build, you can now host the front end of your DApp on a static file hosting service such as GitHub Pages or Netlify. These platforms allow you to serve the optimized pre-built files to your users, providing a seamless and responsive user experience. Now we shall looking at deploying the front end to the GitHub pages. We first install GitHub pages. We use the command npm install github pages dash dash save dash dev command. This package helps us easily deploy our React based frontend to GitHub pages. We then update package.json. In the package.json, add a home page field with the URL where your DApp will be hosted on GitHub pages. Also add pre-deploy and deploy scripts to automate the deployment process. Then, to deploy to our DApps frontend, we run the npm run deploy command. This will first build our production-ready React application using npm run build, and then the GH pages package will automatically publish the build directory to the GitHub pages branch of your repository. To deploy the frontend on Netlify, we first create an account. This cloud-based platform automates the deployment process and provides continuous deployment from your GitHub repository. We then link the GitHub repository. We connect our GitHub account to Netlify, allowing the platform to access and deploy our DApp front-end code directly from the repository. Then we configure the build settings. In Netlify's development settings, specify the build command and the publish directory where your optimized front-end files are located. This ensures Netlify can properly build and deploy the React-based DApp. Now, to connect a React-based frontend to the deployed smart contracts, you will need to update your application to reference the correct contract address and application binary interface. The ABI is a JSON file that describes the contract's functions and the parameters they expect. By importing the ABI and specifying the contract address, our frontend can seamlessly interact with the deployed contract on the Ethereum network. Here, we first import the ABI file for our deployed contract, such as in this case simple storage.json. Then we assign the contract address to a variable such as contract address. Then we finally create a new instance of the contract using the web3 eth.contract constructor, passing in the ABI and the contract address. The simple storage contract instance can now be used to call the contract's functions from your React application.
Ensuring that a DApp can seamlessly handle network changes is crucial for providing a smooth user experience. In the Web3.js based React app, you can detect when the user's Ethereum network changes by listening for the changed event on the window.ethereum object. When the user switches to a different Ethereum network in the MetaMask wallet, your DApp should automatically reload to ensure it interacts with the correct deployed contract and maintains the expected functionality. By reloading the page, your React application can reinitialize its connection to the Ethereum network and update the user interface accordingly. Ensure that our React-based DApp can seamlessly handle user account changes. We need to listen for the accounts changed event on the window.ethereum object. This event is triggered whenever the user changes their active Ethereum account, such as when they switch accounts in their MetaMask wallet. By attaching an event listener to the accounts changed event, you can update the displayed account in your DApps user interface. When this event is triggered, you can extract the new active account from the provided array of accounts and update a state variable, such as setAccount. This will ensure RD app always reflects the user's current Ethereum account, providing a smooth and consistent user experience. Now we shall be testing the deployed DApp. First, we check the contract interactions. Thoroughly test the deployed smart contracts by verifying the key functions and interactions work as expected. Ensure users can read data, update state, and trigger contract events without any issues. We then check the front-end functionality. We rigorously test the React-based front-end to confirm it correctly connects to the deployed contracts, handles user inputs, and displays the expected data and UI behaviors. We then check the network and account handling. We test the DApp's ability to gracefully handle Ethereum network changes and user account switches. We verify the app can reload, reconnect, and updates its state to maintain a seamless user experience. Here are some of the very good security practices we need to follow. We first need to validate our user inputs. We thoroughly need to validate all user inputs to our DApp to prevent vulnerabilities like SQL injection or cross-site scripting attacks. We filter user data before using it in our smart contracts or front-end application. We use HTTPS for front-end. We ensure that our DApp's frontend is served over a secure HTTPS connection to protect user data and prevent man-in-the-middle attacks. This is especially important when users are connecting their Ethereum wallets and interacting with our smart contracts. We should regularly audit our contracts. Periodically conducting smart security audits are very important to identify and address any potential vulnerabilities. Work with experienced blockchain security experts to thoroughly review your contract code and deployment process. Contract monitoring is a very important part in building a DApp. We use tools like Etherscan to monitor the deployed smart contracts of our decentralized application. This allows you to track key metrics such as transaction history, contract state, and event logs. Proactive monitoring helps us identify and address any issues or anomalies in our contract's behavior. We then check the dependency updates. We regularly review and update the dependencies used in our DApps frontend and backend. This includes keeping our React, Web3.js, and other library versions up to date to ensure you have the latest bug fixes, security patches, and feature improvements. Staying on top of dependency updates is crucial for maintaining a secure and reliable DApp. Here are some more resources for you to study.